Hello students and welcome to your first sixth grade math video lesson with your host, Mr. Nerlich. Before we get started, I want to talk about a few things so you understand how these videos work and what your expectations are when watching these videos. So you will have some guided notes. Your guided notes will look something like this. Okay, so you'll have some guided notes, and your guided notes will help you to keep up with the lesson. Now, should you fall behind at any time during the lesson, that is quite okay. Just pause and catch up, because you can pause and rewind the video as much as you need to get in the notes. To keep the lessons from getting boring or too long and try and keep math as fun and as exciting as possible, I will underline on the board when I am writing out the keywords for your notes that will help you. You will also have a keyword bank if needed. And if you're the type of person that you just do not like writing and you prefer to type, there is a digital version of your notes where you can type in the answers to the notes and to the problems that you need to. Okay. At the end of each lesson, there will be some problems in Edpuzzle that were connected to the lesson, and you will have to solve those problems to show your teachers where you are in the learning process of this particular lesson. Now, when you watch the Edpuzzle, you cannot fast forward through the Edpuzzle just to get to the questions and be like, I'm done. You need to watch the video and then answer the questions at the end. As I've set it up so you cannot fast forward through your videos to answer just the questions and move on. All right, so here is your first sixth grade math lesson. All right, so the greatest common factor, or GCF, it is the greatest So it is the greatest factor shared by two numbers. I will be referring it to as the GCF going forward. I may say greatest common factor here and there, but it's a lot easier to say GCF. It's a lot easier to find, or to write, I should say, to write down GCF versus greatest common factor each time. Okay, so when we're trying to find the greatest common factor, we have to use prime factors to determine GCF. And now you see two things. Prime factors. Well, what on earth is a prime factor? Well, let's define what a factor is first, and then we'll figure out what are prime numbers, and then that'll help us determine what are prime factors. So factors are numbers you multiply to get a certain product. And a product, if you recall from your elementary days, product is the answer to a multiplication problem. All right, prime numbers are numbers that have two factors, itself and 1. Okay, so an example, 5 and 8 are factors of what? 5 and 8 are factors of 40. So example 1, let's see, 5 and 8 are factors of 40 because 5 times 8 equals 40. Example number 2. 5 is a prime number because, so why is 5 a prime number? 5 is a prime number because the only factors for 5 are 1 in itself. So for example, 5 times 1 equals 5, or 1 times 5 equals 5. And we'll get into this later in the year, but this is the commutative property of multiplication, and it says I can rewrite the multiplication problem. I can flip the numbers, and it'll still give me the same answer, or product. Okay, but that's for a later time in the year when we get into those properties, and we'll discuss more of that then. All you need to know right now is even if I write it two different ways, I still have only two factors. That's why 5 is a prime number. Now, here comes Dun, dun, dun. Prime factors. So factors of a given number that are always prime. So they're factors of a given number that are always prime. Okay, so let's look at another example. Number 3. All right, so in this example, we're going to look at the number 12. Okay, so we're looking at number 12. And the factors of 12 are 1, 2, 3, 4, 6, 12. All right, now, if you remember in your elementary days, you might have heard of a thing called a factor rainbow. If not, then here it is. So a factor rainbow just says I can connect, which makes kind of like a rainbow here. Okay, so it's kind of like a rainbow. So I now know that my factor pairs, 3 times 4 gets me 12, 2 times 6 gets me 12, and 1 times 12 gets me 12. And I can do the opposite way too, right? Because we said about that property, commutative property, 12 times 1 gets me 12, 6 times 2 gets me 12, and 4 times 3 gets me 12. So now that I know that, that can help me figure out when I'm trying to find my prime factors for numbers in another problem. Okay, so prime factors of 12 are 2 and 3. So let's see. So prime factors of 12, so I'm going to underline that, of 12 are 2 and 3. Okay, and that's because these are factors of 12 that are prime numbers. All right, now we want to see an easy way to find the GCF. And to do the GCF, we're going to use a Venn diagram and some factor trees. Now, a Venn diagram, you're going to say, wait a minute, isn't a Venn diagram only used in language arts or maybe science or social studies? No, that's you may think so, but we're going to use a Venn diagram today in math. And the Venn diagram works exactly the same way as it did or as it does in your classes, your other classes. So for this example, we're going to use 18 and 30. So we want to find, so I have example 4, and I want to find the GCF of 18 and 30. Okay, and this is example number 4. All right, so I always label my Venn diagram just like I would. Let's say I'm reading 2 different stories and I want to compare and contrast how they're the same or different. Or let's say you watched a movie and then you read the book. So, for example, we work with The Lion, the Witch, and the Wardrobe in 6th grade in language arts, and you'll read the book and watch the movie, and you could be asked to compare and contrast how the movies are similar and how they're different. So when you look at this Venn diagram, you know that anything that goes under 18 would be anything that belongs to just 18. Anything that goes under the 30 is just belongs to 30. And then in the middle, it's what these two things have in common. These two numbers have in common with each other. Okay. So we need to start with our factor tree. So I have 18 and 30. And this is where you have to remember, like we just did with 12, what are the factor rainbow? What are some things that multiply together to get me 18? And the first thing that comes to my mind is 9 times 2. Okay, so I know 2 is a prime number. We've discussed that. So then I will circle 2 as it is a prime number. I know 9 is not prime, so I can break that down into 3 times 3. And then I know 3 is prime, so I will circle. Now, some of you may ask, why can't I do 18 times 1? Well, I cannot do 18 times 1 because 1 times 18 is going to give me 18. So I wouldn't break it down any further. I would still have 18 again, so I wouldn't move anywhere. Plus, 1 is not a prime number. It is neither prime or composite. All right, so that's why we can't use 1. A wouldn't help us get anywhere, and B, 1 is neither prime or composite, and we want to find prime factors. So 1 does not help us. 30. I'm going to break 30 down into 6 times 5. And again, if you thought of 3 times 10 or 2 times 15, totally okay. I just try to think of math facts that are most common for me and for you guys that you use. And normally most people say, like, what are some math facts that equal 30? And most people think of 6 times 5. So 5 is prime, which is why I circled it. And then I have 2 times 3, and both of these are circled. Okay? So now here comes I guess the fun part of this is we have to look and say what is similar on both sides. So I see that I have a 2 under 18. So I'm going to cross that out. And I see I have a 2 over here, so I'm going to cross that out. Since I have 2's on both sides, then I know that I have one pair of 2's, and in my Venn diagram, I put a 2. Okay, then I look and I see, oh, look, I see 3's on both sides. So I cross 1 3 and another 3, and I have a set of 3's in the middle. Now remember, you're only writing the number once. You're not putting 2 2's, not a 2 2, but 2 number 2's or 2 number 3's in the middle because it's a pair. It's what they have in common. So they have one set of 2's in common, one set of 3's in common. Now I see another 3, but I don't see another 3 on this side. So that tells me that I do not have 3's in common. Okay, so I use that one. I can cross it out. If you want to keep it uncrossed out to help remind you that it doesn't belong in the middle, that's fine too. I just like to cross all the numbers out that I've used, and then that way that tells me that I'm done once I've crossed out all the numbers. 5 doesn't belong anywhere besides under 30. All right, now with GCF, all we have to do is look at what's in the middle. Okay, and all I do is multiply them. So I multiply 2 times 3, which equals 6. So my GCF for this problem equals 6. Okay, now on your guided notes, it says prime numbers that are the same on both sides. You multiply the numbers in the middle, and that becomes your GCF. So you multiply the numbers in the middle, and that becomes your GCF. So that's just the words that I used to help describe what I did up here. All right. Now, Falcons, I want you to try some problems on your own. And remember, take your time, do your best, because these problems are going to help guide your teachers to where you need to go for the next day in class. So if you take your time and do your best, then we know where we place you. That is an accurate place for you to best help you. Have a great day, Falcons. Keep soaring.